We'll be talking about reactive extensions from Microsoft. So I'm going to circle back to this URL a couple of times, but I know you guys don't have internet here at the conference, so write it down and follow it up afterward. This talk is intended to get you kind of excited, but in order to get anything useful out of it, you're going to have to reference the slide notes, the presenter notes inside of the slides, that sort of thing. Look at the examples after the fact. So, reactive extensions from Microsoft. There's a variety of observable libraries that are available. This one is kind of the granddaddy. You can't go wrong by choosing this one. Some of the other ones have, certain pros and cons to them, but this one is just a safe bet, and it's also one of the most featureful and fastest. So, this is not an introduction. If any of this doesn't tickle your fancy, feel free to leave. You won't hurt my feelings. We're going to go fast. So, reference the slides after the fact. As evidence, this is a 45-minute talk, and we've got 51 slides. So, it is crucial when you're getting into this to have a little self-motivation on the topic. You have to have some expectation of what the payoff is going to be when you dive into this system. It's got a reputation for maybe being a little tough to get up to speed with. That reputation is earned. It is very powerful, but you have to know why you're doing it. If you're doing it because it's popular, it's gaining popularity in the JavaScript community, then you might be having a bad time. So, my sales pitch, and I'll circle back to this at the end, is it is a very mature library. It's been around for 6 years. It is unbelievably solid. Its pedigree goes back farther than that. We'll come back to that. And so it's a very solid thing to build an application with and on. The ideas and the techniques that come from this library, they span many languages, many implementations. You can take the knowledge that you've gained learning Rx and apply that to a variety of different places, not just JavaScript. It will make you unafraid of async, right? That's its bread and butter, and async is hard, and you can do some really complicated things really easily. And if you get into it deep enough, it might just show you new ways to program, right? It talks about ways to compose behaviors and functionality, and there's a lot to it. It's not just promises on steroids, which we'll see. Quick note about RxJS versions. I'm going to be presenting with RxJS 4. Apologies in advance for that. They changed enough that I haven't been able to get up to speed yet on the new version. So RxJS 4, it's in maintenance-only mode. It is rock solid. It has great performance, and it will be maintained for the foreseeable future. There is an awful lot of code that is built on RxJS 4, including services like Bing and Cortana. So RxJS 5 is the future. It's got a lot better performance, better stack traces. It's easier to debug. You can write tests with what are called marble diagrams, which are kind of visualizations of async stuff. So take a look at the migrating from doc in the RxJS 5 documentation. All of the things that we're going to be talking about today apply to both versions, but sometimes the operators have been switched out, the names of the operators have been switched out. So let's start by talking about observables. All right. So it looks like this is something that produces an observable. There's a variety of ways to produce an observable. This one is, of course, making an Ajax request. It's similar to promises on the surface, but they're lazy. That becomes important for reasons we'll get to, and they're cancelable, which is really nice, because if you've got one in flight and it's no longer valid, you can cancel it and you'll never get that result back. So what I'm going to be doing in this presentation is I'm going to be live demoing a bunch of code in the JavaScript console. So that's another reason to reference these code samples after the fact. I'm actually offline. So what I've done is I'm going to spend this presentation bouncing stuff off of the GitHub API. A lot of stuff, in fact, so much so that I've actually set up a mock of the GitHub API using JSON Server, if you've played with that. So when you download the slide notes, you can grab the package.json file, and you can follow along that way. So fetching users, for example. There's 3 callbacks to this subscribe function, similar to a promise, except there's one specifically for values, one specifically for errors, and one specifically for when the stream has completed. And we'll circle back to what completion means. They will not swallow errors like promises will. So if you don't handle an error manually here, then it'll show up in your console. All right. So we're going to start with a few shorthands so that things fit on my slides, and we're going to kind of build on things as we go throughout this presentation. So the very first shorthand we're going to start with is this. What this is going to let us do is this is going to let us console log those 3 conditions that we just talked about really quickly. Okay? So I'm going to jump over here, and OS 10's full screening is going to throw me off. So I'm going to paste that in here so that we have that handy. And let me jump back here and just show you what we'll be doing. So instead of fetching from the GitHub API, I'm just going to call out to /users. And so we can call subscribe, and we get the response back and the completed. So if I swap that out for the result is the same, okay? So there's our first shorthand. All right, they're lazy, unlike promises. And this turns out to be a really nice thing. It sounds simple, but it turns out to be a really nice thing. So we can save this to a variable, the user's variable, and nothing will execute until we actually subscribe to it. So when we subscribe to it, we get an observable back. That observable contains a value. In this case, it'll be an XHR result with a response, status, all of that. So we can then say chain on that, right? So we can say, save that to a variable, and we can then do users.pluck, right, and save that to a variable. And so we're building up kind of a pipeline, but saving each individual part in the chain to a variable. So then we take that user count and we subscribe to that, right? And that kicks everything up, kicks everything off that goes up the chain, right? This is the thing that actually triggers all of the functionality. So let me demo that real quick before we move on. So if I don't subscribe and I run it, nothing happens. Okay? All right. So one more shorthand. This is for making Ajax requests. So it's going to take a URL and any parameters, and it's just going to wrap getting a response back, JSON response back from the server, and then plucking out the response. This is probably not what you want to do in production code. You might actually want that HTTP status, but it'll make the code a little bit shorter here on the screen. So we'll add that. All right, so let's start with combining requests. We're going to talk about Ajax for the first little bit here. Let's start with combining requests. So say we wanted to fetch users and repositories from both of those URLs. We can combine them using a variety of operators depending on what our end goal is, right? So if we use the merge operator, you can see that we fired off 2 XHR results and we got 2 ticks back. So this is something that promises don't do, where it can tick multiple times. It can, the observable can output multiple values, and that's what we got with merge. So one of them is users, one of them is repositories, and merge just outputs whichever one comes back first. So it's not deterministic, it just grabs whichever one comes through first. If you want it to be deterministic, that's concat. So do this, and then when that's done, do the next thing. We've got zip, which will kick off both requests in parallel, and then when the responses come back, it'll combine them into a single emission. So let's take a look at that. Right. So there we've got a single object with both responses as array items, right? So that's a nice way to combine multiple Ajax requests. Zip is unbounded, so you're going to want to be careful that both producers emit at the same rate. Otherwise, you'll run into some memory issues. If you can't guarantee that, this is a good alternative, combine latest. It's got a lot of uses. In this particular example, the end result is pretty much the same as zip. But it'll hang on to cached values of each item to come through that observable. All right, so let's talk about sequential requests. This is going to mimic then chaining on a promise, right? So what we're going to do is we're going to get all users, XHR users. We're going to grab the very first user, and we're going to call flat map. In this context, it's very, very similar to chaining then. Then we're going to grab that user's repositories. Then we're going to grab the first repository for that user. So you can see we're using index lookups in both of these cases. We're just going to grab the first one, keep this simple for now. And then finally, we're going to grab the details for that first repo that we got back for that user, okay? This is not something you're likely to do in a browser environment. Maybe you're writing in Node.js and you're writing a crawler or something like that. But this example is going to be kind of crazy, just to kind of showcase a variety of things. All right. And then this is that same thing, but put all together, right? So we are chaining these flat maps. Flat map is flattening things out like a then does, so we don't have to nest these, but it'll make transitioning to more complicated behavior a little bit more easy to wrap your head around as we go. So let's take a look at it. So we can see the first, let's see, let me do this. Okay. So here we can see on the network tab, we got users, we got the user itself, his repositories, and then the actual repository. So the end result is we emit one time with the details of that repository, which is the name of the repository, how many stars it has, that sort of thing. Okay? So what if we wanted all of the repositories from all users? A little bit more complicated, right? Well, it looks like this. I'm going to output some of these code examples in diff form so that you can see what we're kind of building on top of. So what we're going to do is we're going to take that user list and we're going to explode that out into multiple observable ticks. So this stream is going to tick into this next stream, causing multiple ticks downstream, right? And we're going to do that just by chaining more flat maps. So let's take a look at that. I'm going to clear that out. This is going to produce an awful lot more HTTP requests. For this, let's see, I'm going to save this to a variable and then subscribe to it, and we're going to build on that. All right, here we go. Jump over to the network tab. And we're at 255 requests. That's how much sample data I asked the thing to write. And you can see on the console here we've logged out all 255 of those responses back from the server. So great. Our web crawler is well into functionality here, but that's going to make GitHub angry, right? They've got pretty aggressive rate limiting, it's just hard on system resources all over the line there. So let's limit these requests. And we can do that really easily with a modification of flat map, which is flat map with max concurrent. And we're going to say do 5 at a time, okay? So I'm going to just, let's see. I'll circle back to that. Switching over to flat map with max concurrent, drop in, do 5 at a time. So just batches of 5. And then let's rate limit those as well. Let's rate limit the responses that we get back so that we're not sending out more requests per second than this once per second. And we're going to do that by layering on 2 other operators. We're going to so we've got this observable from, which is the list of all of the users we get back, and we're going to pump that out to the observables downstream at a steady 1 second pace, right? So that's going to serve as a second kind of rate limiting, and so that's where that comes from. Okay, so that's a little bit of boilerplate, right? We've got to do these 3 extra operators, and so what we're going to do is we're going to make a shorthand. So we're going to use what's called a lettable function. A lettable function is just a way to encapsulate some functionality inside of a function that you can then pull into a stream, okay? So we're going to call this list to rate limited stream, and we're going to give it a default delay of 1 second. Okay. I'm going to grab that, clear this out. Okay, so with that in place, now we can make use of it. We're going to swap everything out that we had before with a more succinct thing that uses our let here. So we're going to remove these lines and just add our let. Okay. So we're going to swap out this XHR that we have. And so now when I hit go, we're going to see those requests a lot more slowly. So you can watch here the counter go up. So we're not quite incrementing by 5 each time because we're getting responses back from the subsequent requests, which are piling on. But in any case, you can see that's going an awful lot more slowly than it was before. Okay. All right. So that was pretty easy, right? As far as lines of code go, it's going to take a little while to finish. I'll turn that off in a minute. But as far as lines of code go, we're currently at 32 for everything we've talked about, and just for the rate limiting, right, we're talking about that. So Rx is very, very succinct. Okay, so let's showcase something else Rx can do. We're not going to build on this, but it's just kind of a fun aside. So you can branch off the data that you've got going through a stream, and you can say send this data to this stream and that data to that stream. And so what we've got here is we've got this partition operator, and that's going to say send everybody who's got more stars on their repositories, more than 1,500 stars, to one observable, and send all of the other ones to another observable. And so that lets us do different things with that data. So for example, with people that are under that count, we just want to do a final count. We just want to say this is how many there were. And for people that are over that count, we're going to want to run a reduce operation on that and maybe do some things to that data. Okay. So that might look like this. And I'm going to with that. And one of the things that we're going to need to do is we're going to need to share. This is a multicasting thing, and we can't get into it as part of this talk, but suffice it to say, whenever you've got multiple streams that are all building off of one observable, you often want to multicast that so that it's not repeating work, that it's sharing the work that it does with the multiple subscribers. Okay, so we're going to do count. We're going to run this reduce operation, and we're going to count the number of times that we've seen a particular user. Okay? So if I run that, again, that's going to run a little slowly since we're rate limiting. For the duration of this talk, I'm going to actually turn off the rate limiting since I'm local only. So I'm just going to comment these two out. That'll go a little bit faster. Okay. So now if I run that, you'll see it's kicking off a bunch of XHR calls, and then it outputs it at the end. Total repositories, right? Total stars or superstars seen. So these are the users and how many times we've seen each user. Okay. All right. Well, that's all fine and dandy. We wrote something that can successfully handle 200 HTTP requests for something local only. That's that's a pretty error-free environment. So what if we were to introduce some failure into the equation, right? What I've got here is I've got this JSON server that I mentioned. I'm going to start it in a different mode, which uses a middleware that I added, which takes 2% of the incoming requests and randomly just times them out or throws a 500, right? So we're just going to randomly fail 2% of our requests, and we're going to build on that. All right, so first we're going to catch and replace errors with nothing, right? So if we replace it with nothing, then the things downstream don't tick. Without this, right, as soon as there's an error, it fails the entire stream, and we can handle that, right, with the on-error callback, or we can put a catch, a single catch, at the bottom. that's fine. But that's not what we want. We just want to handle individual errors, right? If there's an individual error, we're just going to ignore it and move on and keep requesting all of the other things that we can, right? So really, we're just adding these catch operators. And then let's say our server times out sometimes, and so we don't want to wait longer than, say, 15 seconds. So we're going to time out as well, and that's just another operator, right? And the order of these operators is almost always important, so keep that in mind as you're playing around locally. All right, so if it times out or if it fails, we want to retry it. Okay? So we're going to do that with this retry when operator, and it takes a notifier argument, and it returns something, right? In this case, we're returning just a flat mapped timer, so we're just going to wait 1 second and then try again. Okay? That's all this is doing. And so that's a few things. So we're going to make yet another shorthand, which is called retry. We're going to default it to these values. And so what we're going to do is we're going to just toss this into places where we want a timeout. If there's a failure or a timeout, we want to retry and then catch any errors. Okay? So let's add that to our mix. I'm going to get rid of the partition. All right, so there's our retry. And so this will retry forever. It'll just keep trying. Let's give it a shot. Go over to our network tab here. See if we can see some 500s. There's a few. I think I didn't properly refresh my browser there. Let's try that again. And so for anything that shows up as a 500, we should see another request for it later on. It seems I've got a syntax error. Oh, thank you very much. Curse of the live demo and being nervous and all of that. Yeah, thanks for pointing that out. Okay, so before I change the code, let's skip ahead once more. So say we don't want to retry forever. Say we want to retry, say, 5 times and then back off. We can add. Let's see. Sorry. Got my slides slightly out of order. My memory of my slides. Okay, there we go. That uses it. Thank you for pointing that out. Okay, so as you can see, without that, as soon as it encountered the first error, it did indeed fail like we were hoping it would. And now that we're handling that in different places, we'll see the individual failures. Okay, there's a few. So you can see it's just happily cruising along. This will be a little bit harder to fish out of the network log. You can see that one's pending, right? It's still pending, so that it hit that random timeout. So it should wait for 10 seconds before trying again. And there it goes. All right. So there we go. Now say we want to back off. What we can do is we can add a little bit more code to that. So we can say, instead of just retrying on this 1 second timer, let's keep track of how many times we've tried to retry using this scan operation. Scan is sort of a reduce over time. We'll talk about it once more toward the end here. And then we're going to calculate whether or not we should back off or not, and whether we should give up or not. So we add this to our lettable function, and so what we have is we've got this drop-in thing that can now retry an observable. And one of the things that is really nice about observables is we don't care if the observable is an Ajax request. We don't care if it's any other kind of asynchronous operation. We don't care if it's a synchronous operation. We deal with them with exactly the same API in all cases. And so this thing that we're building is going to work for WebSocket connections. It's going to work for anything else that might time out or throw an error. So there's that. I'm going to swap out our retry with this Backoff version. There it is. And now if we run that again, we should see roughly the same behavior. I don't have an endpoint set up that we can pull over and over, but you'll see that it works the same as before. Right. So with Backoff, right? That's not a lot of code. If you've ever written something where that pulls something and then does a backoff over time, those can get pretty verbose. And this is all the code that it takes to do that using Rx. All right, let's talk a little bit about progress events. Progress events are useful for a variety of things. What we're going to do is we're going to add them to our XHR wrapper. There's a few ways to do this, right? One is you can do individual sort of progress reporters that say these are things that you can use to monitor, how long an upload is taking or a download, with the individual progress ticks. When you have it global like this, you can also very, very easily monitor all of the Ajax requests that are happening across the entire system. And it turns out you can do some kind of interesting things with those, one of which is just logging, right, which is nice for debugging. So this is a short drop-in. We're just going to make this subject. Subject is sort of a bridge to an imperative system. We'll talk about it again in just a moment when we talk about React. We're going to make a request ID. We don't need one here, but it's an easy drop-in, and it makes tracking individual requests a little bit easier. And then we're just going to push the values through this progress subject so that we can then watch it. So let's swap out our XHR implementation. And with that in place, we can then subscribe to it. So down here, we can subscribe to it just like the other thing, XHR progress, subscribe. Oops. Progress. Okay. So now if I run this again, we're going to see these progress events for every single one. These can be kind of interesting to look through for debugging. So like one of the things we do in real application code is we maintain, we'll talk about this in a minute with React, but we watch all of the things, all of the actions that the user is taking, and we log those, and we also log all of the Ajax responses, so that when the user encounters an error, he can give us this log, and we've got this huge log of all of the things that happened within the app. So there's our request ID, and a lot of these are going to be these are just standard HTML progress events. So load, pending, that sort of thing. Okay, so easy drop-in. Now we can see all of the Ajax requests that are going on. So like one of the things we can do for that is we can watch for server errors. So say we wanted to have an application-wide toast notification whenever our connection to the server goes down. Well, we can, or has a failure. Whenever we get a 500 response, then we can bark that to the page. And this is an easy thing to do here at the console. So we're going to filter out the progress event type. We're going to pluck out the status code and write that. So if I were to do that, let's get rid of this subscriber. And I'm actually going to remove this so that we don't have all of the additional noise of the results that are coming back from the server. So now if I run this, whenever we hit a 500 error, that individually will be logged out. We can just see them as they happen. So nice, easy addition. All right. So what if we wanted to do something more complicated? What if we, say, wanted to have a little Ajax spinner in the bottom corner of our page? So whenever any Ajax request anywhere in the app was in progress, we wanted it to do something. And maybe we wanted it to do something really fancy, right? Like say, which Ajax requests were in progress or something like that. Well, that's just as easy a drop-in, right? So this is something that's monitoring its XHR progress. It's running the scan operation, which, as I mentioned, is a reduce over time. So every time an item comes in, it goes through that reduce algorithm and adds it to the accumulator. And we're using that request ID that I mentioned before to decide which ones are which, right? And so this is a new Again, another easy thing to drop in. Let's see, I can get rid of that now. So if I were to subscribe to this, now we've got this map. As you can see, it's getting changed over time, where XHR responses or requests are getting added to it and removed from it as they either error or complete. So that is a lot of information, really granular stuff with just that tiny bit of code as a drop-in. All right, say we wanted to poll and tell a condition. If you guys ever run up against this where you need to hit an endpoint which returns an empty response because it's kicked off some long-running server process. And so now you need to poll it every so often for it to not be empty, right? Same kind of deal as repeating, except what we're going to do is we're going to use repeat win. So every 10 seconds, we're just going to repeat the thing that comes above it. We're just going to repeat this XHR call. And we don't want it to repeat forever. We want it to tell it when to stop repeating. This is one of the things that Rx does so nicely is we can tell it when to stop listening. So we're going to use take and tell. And we're going to listen to our progress observable once again. And we're going to filter on the path that we're querying. And we're going to wait until the response is either not null or not an empty string. Right? Straightforward again. We can cache responses. There's an awful lot to say about this, more than we can fit into in this talk. Suffice it to say, you can cache responses and reuse them with an operator like this. There's some garbage collection kind of nuance to this, which we don't have time to get into. But in any case, if you just want to hang on to a response and have other observables pick that up if it's available, it's a nice drop-in. All right. So let's actually render something on a page. Whoops. So what we're going to do is we're going to wrap our observable that we've been using in a function, right? And this is a common thing to do with observables, but we don't have to, right? So if you don't want to wrap it in a function, right, because there's no reason to, observables are lazy. You don't need to do that. And that's one of the nice things about them is you can just pass them around as though they were, kind of like functions, right? It's something that represents functionality that will be invoked or called, right, at some point. So oftentimes when you wrap something in a function, you do it for runtime or parse time, I should say, configuration. It doesn't trigger anything, right? It's a function that returns an observable, and so that observable doesn't trigger until you subscribe to it. But this way we can say modify the rate limiting and the retry after parameters on a case-by-case basis. So that looks like this. I'm going to swap out this that we've been calling with that, which is just that wrapped in a function. The other thing we're doing here is we're returning both the repository and the user that repository belongs to. And we just made this change, right, where we're grabbing the argument, which is the user. Where is it? Not here. Where we're grabbing the user parameter, and so we're passing both downstream. So before, where we were just outputting the repository that was at the very end of that chain, now we're outputting the user that repository belongs to. Okay. And so this is kind of the first thing that we've seen where we've got a bit of data flow that's going through several things and ending up at some final destination. So this is the function we just made. Then we're going to run that through a scan operation, and that's going to sum all of the stars for a given user. So it's going to grab all of the repositories for that user, and it's going to sum all of the stars across all of that user's repositories. Then what we're going to do is we're just going to reformat that slightly so that it's a list of objects rather than an object. And then we're going to map that again over visualizing that data structure. So we're just taking a data structure and we're massaging it through this stream, right? We're summarizing it, we're changing the shape of the data, and then with this last map, we're actually taking that data and we're reformatting it into something wildly different like HTML or VDOM if you're using React. And at the very end here, we're going to actually call render. So there's that pipeline. Of course, we're missing a few of these functions, so let's take a look at them, see what they're doing. So we're going to aggregate some results, right? And it's really just as simple as this. We're going to hang on to each user. For each repository that comes through this, this function, we're going to sum the stars with the last one that we saw. This is just a regular old reduce operation. Now we're going to format those results as HTML. So what we're doing is we're getting that list that I mentioned, and we're mapping over it. And for each list, we're going to output for each repository, or excuse me, for each user, we're going to output a div. We're going to float it left, and then we're going to output that that user's avatar and how many stars that user has total. Okay. And then finally, we're going to render it. In this case, we're going to say, give us a container element. We're going to select that, and then we're going to return another function that actually does the rendering each time something comes through. And we're going to keep this one light, and we're just going to call inner HTML for each time this observable emits. There is a world of things you can do to optimize this. Obviously, using something like React instead of inner HTML will gain you a lot. You can also output this on a particular schedule. So you can say, tie this this call to render to request animation frame, and that's a one-line addition to this. So you can say only render on request animation frame. So easy to do. All right, with that in place, let's run it. And we're going to start to see our users show up. And as additional responses come back from many repositories, the old score is going to be updated with the new sum. All right, so that's kind of the end of the hands-on portion of this, and I'm going to be talking about a few other things, but this is the part that I would invite you to play around with, right? Pull this code down, play around with it. You can't learn Rx without playing around with it, in my opinion. All right, if you're thinking to yourself that data pipeline where we were transforming store data to view data looked an awful lot like Flux, you're right to wonder. So let's talk about that. This is what Flux might look like if you implemented in Rx. There's a lot of ways to go about this. This is one possible way. So one is we're going to make another subject here, and that's going to represent our actions. Now, a lot of people in the Rx community are going to tell you that the subject should be avoided, and generally that's true, right? You get observables from places, right? You get an observer that represents DOM clicks. You get an observer that represents an observable, that represents an Ajax response or a WebSocket connection or a web worker, right? So you get them from places, but every so often you need to bridge Rx into an imperative system, which is React. React is an imperative system with some functional parts, but so this the subject's going to be our bridge into that, and then we're going to make this little function here that's going to push data into it. So when the user clicks or something like that, it's going to push data into our action subject. From there on out, we're going to make a dispatcher. We don't need one, but it's a nice central place to bottleneck data through, which is really nice for, say, logging, right? As I mentioned before, if you want to know all of the Ajax requests that are happening in your system, as well as all of the things that the user's doing, because that's going to go through your dispatcher. There you go. So we're going to make the dispatcher, which is just a read-only view of actions. That's it. That's going to broadcast out to all of the stores that we have listening to it. So here's an example store. You'd have many. So the dispatcher is filtering on, say, some tag, right? This is one possible way to do it that allows you to send different things to different parts of your app. If you do this, I highly recommend namespacing these tags so that you can more granularly say which parts of your app, which tags go to which parts of your app. And then we're going to flat map the same thing that we just saw before, right? This is the same function that we just called before. We're going to flat map that in. We're going to run that scan, same as we just had, and then we're going to reformat that data structure so that it's a list of objects, right? So there's our store. Our view is the exact same thing. It's keying off of the store there. And then I'm going to do a little hand-wavy stuff, and we're going to have an application that we're going to subscribe to. And we do this in one place, right? So the things that are missing from this particular demo are, things like routing, things like a way to collect all of these views into a central place so that you can, just manage them centrally. And I'm not here to pimp a framework. If you're interested in this kind of thing, talk to me afterward. I've got a repository on my GitHub account that collects some of these ideas. All right, let's go over some miscellaneous stuff. The Komami Code, it's just kind of fun. These are the up, up, down, down, left, right, so if we toss this in. Right, now we can do up, up, down, down, left, right, A, B. Whoops, I'm doing Ajax at the same time. I should comment that out. Which is here. Okay. So now if I do up, up, down, down, left, right, A, B. Oh, it's BA. There we go. Konami. So that's kind of a nice, succinct Konami code. It's just fun to look at. Drag and drop, same kind of a thing. I'm not going to go over this in detail. Noteworthy here is you're not removing any event listeners. You're not saying, I only care about these events for this amount of time. You're not removing anything manually. It looks like this. Super straightforward. Go through the code when you have time. All right, so we've been talking a bit. We're running up on the end here. So what is reactive extensions? Well, it's more than Lodash for async. If you've heard that tag phrase before, it's way more than that. It's a common specification. It's a lingua franca across 20 different languages or environments. They're listed here, right? So if you learn Rx in one language, a lot of those ideas are going to be applicable in the other language. There's going to be differences, right? In JavaScript, we don't have threads or processes, but we do have web workers, so there's a little similarity there. But if you kick off a job in another process in a language that does support those, the API is going to be very, very similar. It comes from a rich heritage of ideas going back a decade or more into 2007, maybe earlier, right? ReactiveX stems from Link, right? Which was a big deal in the Microsoft world. That borrowed a lot of ideas from SQL and from Haskell. And that borrowed a lot of ideas from category theory, which is an entire branch of mathematics devoted to how to combine functionality, how to compose functionality, right? Whenever you hear the phrase favor composition over inheritance, category theory is that taken to the nth degree, right? That is how you compose functions in the most extreme way possible. And so the deeper you get into Rx, the more of this you can unpack if you're interested, if you want to. So it's a unified API for async operations, sure. But it's also something that allows both the consumer and the producer to have control, right? If you're listening to a stream, you can decide when you want to stop listening. If you are the producer, you can say, well, there are no more values coming, right? You can control that from both ends, which is really nice. You can do resource allocation and automatic cleanup, right? You can say, stand up a web worker, and when it's done, you can say, clean it up and destroy all of that. That's how event listeners are removed from the DOM automatically. When all of the subscribers drop off, you can say, or when your listeners drop off, or you unsubscribe, you can say, clean up that event handler. And sky's the limit as to what you can clean up there. It's totally open-ended. They're easy to write. It performs subscription tracking. This is a really powerful thing as well, right? If you've got something that's being multicast out to a lot of different observers, you can watch when they start to drop off, and you can decide, say, when to clean up XHR resources. We've got this really complex thing at my work that tracks XHR calls and e-tags. And so it sends an e-tag, if it has one, on subsequent requests to see if there's anything newer. And we use subscription tracking to decide when to dump our cache. So it's useful for composition, data flow, messaging, state management, async streams, processes, threads, coroutines, workers. It is a very, very open-ended library. So let's end with some resources so that you know where to dive in if you are indeed interested. The very first thing, play with this code. Like I said, there's the repository. Pull up a browser console like I was doing here and try it. That is the thing that got me over the hump. use subjects, right? Even though they're frowned on in Rx, they're great for playing around because you can be very slow and deliberate and you can push things through on your pace manually. And keep your experiments small and single focused. It is really easy to get over your head in Rx. It is complicated and it lets you do amazing things. And so you got to take it step by step. So these are good resources. The links to each of these are in the slides, so grab those. The Introduction to Reactive Programming and Subjects and Multicasting are both on Egghead by Andre Staltz. They're great watches. Learning observables by building observables. This is a great way to break down the magic that is observables, right? Because you build one and it's kind of not a big deal once you get in there. And so that's a great way to kind of get over the hump. There are a million operators in Rx, as I'm sure you've seen if you've looked at it at all. And so these decision trees are key to finding out, once you know kind of the basics of what is going on, you're going to need to know if there's any operators that implement what you need to do. And so you go through this decision tree. I've got A and I need to, right? And you just follow the tree. So these are invaluable. Incidentally, the way this goes is 80% of the time, there's going to be an operator that does what you need it to do. 10% of the time, there's going to be an operator that does what you need it to do, but you're going to find out about it 6 months later after you rolled your own. And then 10% of the time, there's not an operator. And then these last two links are well worth pulling up. One is an implementation of Snake in Rx. The code is tiny. It clocks in at like 120 lines. It's just a blast to read through. And then Ben Lash, the guy who maintains RX5, has a really fun talk where he actually animates some things with some easing functions. And so that's a fun watch. And we're over time. Thank you for coming. I'm available for questions out in the hall if you guys want to talk about this stuff. I really enjoy talking about this stuff.